Greetings and welcome to the new Calculus channel. My name is John Gabriel. And in today's video, I'm going to show you how to solve a simple problem which is usually made into a very complicated problem because people, such as teachers, don't really understand what they're doing and don't really know how to explain these things, don't really know how to solve problems. As a result, students never really understand. So let's begin. One of the problems that regularly comes up is in algebra, that is one that involves, filling pools in a number of time and finding out how much time it would take one hose to fill the pool when two hoses take so much time, or there are so many variations of this problem, but they all center around one particular idea, the idea of realizing what the rate in each case is, because in each of these cases there is a rate involved, and the problem is purposely stated as follows. No, that's not the one. Purposely stated as follows, as you see in this dark text here: two hoses together fill a pool in 2 hours. Fill a pool in 2 hours. If only hose A is used, the pool fills in 3 hours. How long would it take to fill the pool if only hose B were used? So it's purposely stated with very little information so that you can become creative in the way you solve it. Now, let's see how one of the experts, so-called experts in the mainstream, actually solves it. So first of all, he says here, basic calculation is easy, but I still want to cheat. So he shows a little cheat way of doing it. And the cheat way is correct. It's not really a cheat way. It's a logical way of doing it. So it makes perfect sense. But in any case, then he goes on to a more proper way, whatever that means. It's either proper or it's not proper. It can't be more proper, okay? And that's the first red flag. So you'll see then that he says, let A be the proportion of pull. Well, actually, A is not at all the proportion of pull. Okay, so the A and the B that he uses here are actually the rates of each of the hoses. In other words, so many volumes of water per unit of time, okay? And so he does this little calculation here, and he gets the correct answer, which is 6 hours. But you can see that he doesn't fully understand the problem. He's just had a lot of practice, and so he knows how to formulate these problems, okay, and how to solve them because of having had that amount of practice. But you tend to think to yourself, well, how does he get this answer here? Well, it's evident he doesn't understand it, because if A and B are proportions of the pool and you multiply it by the time, you're not going to get 1 hour time. You're going to get one whole pool, okay? The volume of one whole pool. So let's just get rid of that and look at the correct way of doing it. So don't be afraid to use as many variables as you can. So here's a little guide for you in this little red box, because most of them will end up canceling out. And it's important to understand the problem before you start to solve it. Understanding it, 3/4 of understanding it, is identifying the main rate. And sometimes there is more than one way of solving the problem. In other words, several rates, right? Now, the main rate in this case is volume over time, or time over volume, which is the reciprocal of the main rate. So let the volume of the pool be V, right? That means it contains V cubic units, whatever they are. So hose A fills the pool at a rate of V over 3, okay? That's the rate, V over 3 hours, because it says if hose A is used alone, the pool fills in 3 hours. And similarly, if A and B are used to fill the pool, the rate is V over 2, right? Because V over 3 times 3 is the whole volume of the pool. And similarly, V over 2 times 2 is the volume of the pool. Very simple, isn't it? So the rate of b would just be the bigger rate, which is v over 2, minus the smaller rate. Why is v over 3 smaller? Because a bigger denominator means a smaller value, right? Okay, so that's why the rate of b would be this value here. So now we don't know how much time we'd need to take for hose B to fill the pool if it were used alone. So we'll let it be time t and multiply it by the rate and let it equal to v. Now notice that in this equation, by the way, v over 2 is equal to 3v over 6 and 2v over 6 is equal to v over 3. They're just equivalent fractions. And obviously 3v over 6 minus 2v over 6 is just v over 6 times t. And if we divide everything by v, we just have t over 6 equal to 1, which means that we have t equal to 6. And that is the right answer. There's a tendency now to write, in many cases, to write t over 2 where t is time. That's completely wrong because that's a proportion of times, okay? And it doesn't explain how the problem works. So the best thing to do in these problems is what I just outlined here, is identify the main rate and don't worry about using extra variables because it's not a problem. They usually end up canceling out. So I hope you've enjoyed this little presentation. It's very simple, but I've seen so many students battle with this kind of problem, and I know that many who even go on and get a degree in mathematics don't actually understand it. So I'm going to leave it at that. My name is John Gabriel. This is a new calculus channel. If you are not already a subscriber, become a subscriber, and I'll be talking with you again soon about some other interesting topic. Till next time, goodbye.